beautiful people, and welcome. In today's video, we're going to be introducing functions. As always, if I make a mistake, let me know so I can learn from my mistakes. A function is a type of relation in which there's only one output for every input value. So what you're going to need to know regarding functions, and you're going to need to know this specific definition. For every one input, there is one output. So in my class, what we like to do is we like to remember the function this way. 1, 2, 1. So what I usually do is I just flash my fingers like this. So when someone says, hey, what's a function? And I go this and this. I just flash my fingers like this because it is one input, one output. Now remember how in our previous video we want to sing our alphabet? Ooh, maybe it wasn't in our previous video. Maybe I'm thinking ahead. We're going to be singing the alphabet in this video. Okay, so let's sing the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. I think I went too far. Let's try again. A, B, C, D, E, F, G, H, I. That's what I'm looking for. I'm looking for letter I. So I, J, K, L, M, N, O. So in the alphabet, I comes before O. So do you see how input comes before output? So one input to one output. We're going to be talking about that a little bit more, not a little bit more. We're going to be talking about that a lot more in this video. But let's first talk about a relationship. So when you see two people walking down on your campus in school or down the street, doesn't matter. They have a relation with each other, or what I like to call a relationship. So let's say we're walking down the street. How do you know if two individuals are in a relationship? What are they doing? Sometimes they're holding hands. Sometimes they're giving each other a hug, maybe giving each other a little kiss. So how do you know two people are in a relationship? They're doing something, right? Something tells us they're holding hands or walking down the street holding hands, tells the other people that they are in a relationship. If two individuals are married, maybe they're wearing rings, those two people are in a relationship. So numbers also have a relationship between each other. They have a relation. They are a relation. So let's say we have, for example, two numbers, 2 and 4. If I just write 2 and 4 like this, that's 24. That's simply 24. So how do I show that these are two individual numbers? I'm going to show these are two different numbers by writing a comma. So I have 2, 4. Now, these two numbers still don't have a relationship with each other because they're just two random numbers. It's like seeing two random people walking down the street. How do you know they're in a relationship if they're not doing anything? Maybe they're in a relationship, maybe they're not in a relationship. I don't know. So in order to see if two numbers have a relationship, in order to see if two people have a relationship with each other, are in a relationship with each other, we're going to have to put parentheses. We're going to have to group those people together. So parentheses are actually grouping things. They're putting things in a relationship. So now we know that 2, 4 those two numbers have a relationship with each other. So what does that mean? Well, now this is an ordered pair. And we're going to use that to graph the ordered pair. So how do we know something is a relationship with each other? It is grouped. It has a comma between it, and we know that these two numbers have a relationship with each other. So let's say we have our graph here, our Cartesian plane, the fancy way of saying here's your x-axis, here's your y-axis, here's your negative x, here's your negative y. So how do we graph this? Well, two other things have a relationship with each other, and usually you should know this when we're solving equations. You know that the most common relationship is between x and y. Usually when you're solving an equation, people say, hey, solve for x. Or they're saying, hey, solve for y. So x and y are two numbers or two letters. They're two variables. How about them? Two variables, and a variable represents an unknown number. So here's your x, here's your y. X's are our inputs, y are our outputs. I'm going to input x into a gumball machine, and out comes the actual gumball, and that is my y. So again, what comes first in the alphabet? Alphabet is super duper important in this video. Let's sing the alphabet again. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. So X comes first in the alphabet, followed by Y. So what you're doing when you're graphing whatever comes first in the alphabet. X comes first in the alphabet, so you're using this number first. So if we're doing 2, let's do 2. Here's 1, here's 2, and I'm actually going to do like a little dash line, and I'm doing 4. So 1, 2, 3, 4, and I'm doing a dash line. Notice where those two dashed lines intersect. That is where you're going to graph your point. You're going to plot that point onto your graph. So without the lines, let's do this really quickly. Without the lines, it should look like this. So the lines are pretend. Do not draw these lines. The lines are pretend. The only thing you're graphing is the relationship, and the relationship is 2, 4, and that relationship is right here, that dot. All right, beautiful people, let's talk a little bit more about a relationship. In a graph, sometimes you're going to be given this. You're only going to get part of a graph. So like, here's your other part, here's the other part. Because the other parts are negative, sometimes in a problem, we don't need any negative values. So let's say you're doing something like this, something like this, then we have something like that, then we have something like this, and then we have something like that. So here's 1, 2, 3, 4, 5, 6. Now, oh, just kidding, 5. There's only 5. On your test or on your quiz, you're going to get a question like this, and it's going to say, hey, describe the relation. What is happening? Tell me what's happening. So what you're looking for when you have a question like this is what's happening in 1, what's happening in 2, what's happening in 3, what's happening in 4, and what's happening in 5. Down here is going to be your time. You could be in minutes, hours. Let's do hours on this one. And this right here is going to be your distance. And that could be feet, miles, yards. Let's do miles. So let's pretend I am at home. Here's my home. That's my starting destination because time here is 0 and distance is 0. So that means I am at home. I have not left anywhere. Now I start driving to go to work. Notice that my distance has now increased and my time has now increased. So in 1, I started driving to work. Then notice my distance increased from 1 to 2. And notice my time increased from 1 to 2. Then notice my distance increase in 3, and notice my time increase in 3. Notice my distance decrease in 4. So 4 goes down, but my time still increases, and 5 goes all the way down. But notice my time still increases. So when they're trying to give you this question, sometimes they'll tell you to graph the situation, or they'll tell you to explain the situation. And what we're doing right now, we're going to explain the situation. So the situation is I am at home and I'm driving to work. What is happening? So at 1, what is happening? Well, my distance increases and my time increases. So I'm going to write, I start driving to work. Now, something is different from 1 to 2. So notice the difference between my 1 section and notice the difference between my 2 section. My 1 section is a little bit smaller in my distance. So my distance is greater for 2. I go up more in 2. However, my time is shorter. So in a real world situation, what takes less time but greater distance? So for 2, I'm saying I realize that I'm late and I start driving faster. I start driving faster. I press on that gas pedal because I'm like, oh snap, I'm going to be late. Then notice that my distance in 3 doesn't change. Now, time is forever going. Unfortunately, there's no way of stopping time. And if you have realized that, good for you. And if you know how to stop time, please come and tell me. Now, time never stops, so the time is still increasing. However, notice that my distance line, it stops. I'm not moving. So what would a real world situation be for something that is just a horizontal line? And I'm thinking if time is going, but I'm not moving, I'm thinking maybe stoplight, stop, light. I hit a red light and I needed to stand there for a few minutes, or this is hours, for a while then. Then notice that for number 4, I go down. So maybe I forgot something at home, or my stoplight. Ooh, you know what? Instead of writing stoplight, I can be saying that I got to school. I arrived at my destination, or maybe a stoplight. Either way, time is going. However, I'm not moving. So maybe I parked the car and I stopped driving. So then for number 4, looks like distance is going down. So that means my distance away from home is decreasing. So maybe I start driving home. And then notice again, time is now time is now smaller, but my distance from here to here is much greater than my distance from here to here. So what is, again, greater distance, but shorter amount of time? So I'm starting to speed a little bit. Maybe I really want to get home. Or maybe I got on the freeway. This was the side streets and this is the freeway. And I'm going to start driving faster. And then this point right here, I'm going to call this 6. And I'm going to say arrive back home. So what you need to understand from this example here is if time is less, but distance is greater, that means you're going faster. If you are more steep, that means it's almost vertical. The straighter the line is this way, that means you are moving faster. The more the line is like this, that means you are moving slower. All right, beautiful people, let's talk a little bit more about inputs and outputs. I mentioned previously in this video a gumball machine, I believe. So let's talk about a gumball machine. Now, I'm not fancy, so my gumball machine is going to look like this. Here is going to be your money. Here's going to be your output is your gumball. So input is whatever you're inputting. So in this case, money. And output is your, I guess, reward in a way. What do you get at the end? If this is a gumball machine and there's, gumballs, there's gumballs here. You input, let's say 25 cents, and your output is a gumball. But what happens inside? Something has to happen inside. And inside, there's like a rule or a mechanism, something that takes the money, you do the little twirly thing, and then something happens on the inside. Same thing with function. Same thing with function and relations. So let's talk about relation. Here's our gumball machine. we're going to have to do an input. Something's going to come out. And inside is our rule. And our rule is what's happening? Kind of like what's happening. So let's do an example. Let's do an example of x minus 2 is equal to y. So what am I going to be inputting? And what am I going to output? I guess the arrow's that way. So I'm going to input x values. And my output is my answer or my y values. So how would that look like? Well, let's do this. I'm going to keep it in black here. I'm going to input 5. I'm going to substitute in 5. Here's my rule. So I'm going to say 5 minus 2 is equal to y. My output is y. So what is 5 minus 2? 5 minus 2 is 3. So my input was 5. My output was 3. Input, output. What am I inputting? 5. What is my output? What's my reward? 3. So let's talk a little bit. Now, here's your first thinking bubble, and this is a really important thinking bubble. When we have input, we have our x values. This is called the domain. When we have our output, we have our y values. This is called the range. Now again, we're going to sing the alphabet. A, B, C, D, E, F, G, H, I. I is before O, so this is first. This is second. Let's do it for X and Y. Again, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. So X is first, Y is second. Let's do it again for domain and range. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R. So again, the domain D is first, then is R second. So notice how all of these in the alphabet come first, and then all of these in the alphabet come second. Okay, input, output, X and Y, domain, range. So that's the easiest way that I can recommend you remembering these. So when it's asking you, what is the domain? So let's do an example. Let's actually not do an example. Let me write this out. The domain are all possible x values. The range are all possible y values. When you're doing domain and range, you have 2 questions that you need to ask yourself. What can x be? What can y be? Or you can ask yourself 2 other questions. You can ask yourself, what can x not be? What can y not be? Now let's do the example. So let's say we have an example of 5x minus 2 is equal to y. And they're asking us, hey, tell me what the domain is. Tell me what the range is. So when you are telling us what the domain and range is, you're going to ask yourself these questions. What can x be? What can I input in for x? So when I'm solving, what can I put in the place of x? Can I put a 1 in the place of x? Can I have 5 times 1 minus 2? Sure, why not? 5 times 1 is 5 minus 2, that's 3. Can we do 5 times negative? Can a negative go in here? Can I do 5 times negative 2? Well, 5 times negative 2 is negative 10. Minus 2, that's negative 12. Okay, so I did a positive number, I did a negative number. What about 0? Can x be 0? 5 times 0 is 0, minus 2 is minus 2, negative 2. So x can be 0, x can be positive, is there any number? Can I put 3,000 here? Sure. I don't know what that is, but my calculator can solve it for me. Can I put negative 10,000? Can I put 3.576? Sure. I can put in whatever I want. There's nothing stopping me putting anything there. So for the range, for this example, what can x be? X can be all real numbers, or you can do a symbol like this. There's a line, then from the first line, you're going to draw R like this. This is the symbol for all real numbers. This is me writing it out. This is the symbol. Now, if I put anything here, what is my output? Here's my input. So if I put 3, my output will be a number. If I put 7, my output will be a number. If I put negative, my output will be a negative number. If I put 0, my output is negative 2. So what is my output? If your domain is all real numbers, your range, nothing is stopping my output from being anything that I need it to be. So range in this example is all real numbers. Now, this is not always true. There could be some exceptions. Okay, there could be some exceptions. So when they're telling you, let's do an example like this. Let's do x minus 2 divided by x, let's do plus 1. When you have something like this, and you have x in a denominator, that's where things get a little bit fuzzy. So what can x be? And what can y be? Here's your domain, here's your range. And we're saying, hey, what can x be? What can y be? I can put anything I want in here. However, note that the denominator, so that the one on the bottom cannot equal 0. This cannot equal 0. When we have a 0 in the denominator, the world explodes. It doesn't exist. So what can x not be? If I put a negative 1 here, negative 1 plus 1 is 0. That means I cannot input, again, I cannot input a negative 1. So x cannot equal negative 1. So what can x be? What can y be? Excuse me, what can x be? X can be all the numbers except negative 1. That is not in your domain. So if x cannot be, what about y? What can y be? Well, can y be anything? Sure, y can still be anything because we can get all the numbers. The only thing is that we can't get negative 1 here. So for my range, we still have all real numbers. We can get anything in there, as long as we don't input negative 1. All right, now let's talk about how to write domain and range in like a set form. So sometimes what you're going to get is you're going to get examples like this. You're going to get examples that say, solve for the given domain. Notice that when they give you domain, this is how it looks like. This is your domain. That means these are your inputs. That means this is all of your x values and the only x values. So when you're given something like this, you're going to have to do a t-chart. And I'm going to make a big t-chart. Here's your X, here's your input, here's your Y, here's your output. In here, you're going to show me your work. So I'm going to say, what are my domains? What are my inputs? -2, -1, 0, 1, and 2. So what do? I'm going to rewrite what I have, except where I have X, I'm going to leave a blank. And then here's my Y. So I only need to write the meat of the problem. Oops. Now, I gave you pretty numbers for your domain because this is an introductory video. Sometimes you're going to see fractions here, so make sure you know how to work with fractions. All right, so what am I going to do now? I'm going to input my domain. I'm going to input all of my numbers in here. And then what's going to happen is I'm going to solve. So now I have 5 times -2, that's -10. -10 minus 3 is -13. 5 times -1 is -5, minus 3, 5, 6, 7, 8, that's -8. Then we have 5 times 0 is 0, minus 3 is -3. 5 times 1 is 5, minus 3, that's 2. 5 times 2 is 10, minus 3, that's 7. So then it's going to ask you, hey, we know your domain, so tell me what your range is. So your range is all of your Y values. So all of these are your range. So how do you write them? Step number 1 is you have to put squiggly brackets. Step number 2 is you have to go from smallest to largest number. So first big negatives, then small negatives, then small positives, then bigger positives. So smaller to larger. So they must have squiggly brackets. They must be separated by commas. They must be in order from small to large. So you want to go from your negative values to your big positives. All right, beautiful people, I'm going to go ahead and wrap up this video so it's not too long. Thank you so much for watching. In our next video, I'm going to talk a little bit more about how to write domain and range. We'll work on some examples. And as always, thank you so much for watching, and I will see you in the next video.